Hello everyone, my name is Ashley Rose Johnson, and today we will be conducting a simple regression. Our agenda includes an introduction to linear regression and our regression dataset, our first, second, and third regression tests, key takeaways from the presentation, and we'll close with any questions you may have. Introduction. First, what is linear regression? Linear regression is a basic and commonly used type of predictive analysis. What do we use regression for? We can use regression for determining the strength of predictors, forecasting an effect, or trend forecasting. Rejection rule. We reject the null hypothesis when p is less than alpha, where alpha equals to 0.05. Our first regression test. Can we predict an individual's debt by knowing their income? In this test, the dependent variable is the debt and the independent variable is the income. Second regression test. Can we predict an individual's savings by knowing their income? In the second test, the dependent variable is the savings and the independent variable is the income. And for our last and third regression test, can we predict an individual's portfolio value by knowing their savings? In this test, our dependent variable is the stocks and our independent variable is the savings. For our first hypothesis test, the following regression was conducted. Null hypothesis. The regression coefficient beta is 0. Alternative hypothesis. The regression coefficient is not 0. A simple linear regression was conducted to determine whether debt could be predicted from income. From the linear regression done on PSPP, we know that income is our regressor. We know beta equals to negative 0.05, r squared equals to 0, and our p-value is 0.535. From our findings, we can conclude no significant regression was found. For our second hypothesis test, the following regression was conducted. Null hypothesis. The regression coefficient is 0. Alternative hypothesis. The regression coefficient is non-zero. A simple linear regression was conducted to determine whether savings could be predicted from income. From the results, we know that beta equals to 0.91, r squared equals to 0.82, and the p-value equals to 0.00. Therefore, we can reject the null hypothesis and predicted savings, where savings equals to 0.91 times income minus 203.47. Savings is predicted to decrease as income increases. Further, the 95% confidence interval 0.09 and 0.11 does not contain 0, which lends support to the prediction. For our third and final hypothesis test, the following regression was conducted. Null hypothesis. The regression coefficient is 0. Alternative hypothesis. The regression coefficient is non-zero. A simple linear regression was conducted to determine whether stocks could be predicted from savings. From the results, we know that beta equals 0.28, r squared equals 0.07, and the p-value is equal to 0.000. Therefore, we can reject the null hypothesis and predicted stocks, where stocks equals to 0.28 times savings plus 1006.73. Stocks is predicted to decrease as savings increases. Further, the 95% confidence interval 0.07, and 0.25 does not contain 0, which lends support to the prediction. Before we conclude, let's go over some key takeaways from the presentation. Performing linear regression. We can use PSPP to perform a linear regression. When in PSPP, you can perform a regression by going into the menu bar and selecting Analyze, then Regression, then Linear. After you run the test and receive your results, the key findings that are needed are the coefficient, confidence interval, and R. Thanks to the PSPP software, conducting different statistical tests are much easier than any manual calculations. I would like to take a moment and thank you all for watching. Please leave any questions in the comments below or in the discussion board.